even if you have a good basic English, to talk about
Jay,
chemistry.
I really honestly I don't know, but I think that they have a relatively good understanding of intelligence, but I'm not sure. Quite fortunately, in Korean education system, a lot of the science terminology is still using English as it is. So that thing is usually even okay. But I think someone here, shop rooms, gonna kind of summary review, why you have some 5 or 10 minutes break. So I think that someone will help them understand the main points and everything. So your case, perhaps treat them as relatively normal, students, but you may not speak too fast or so. I mean, relatively standard speed. And also we record it just in case, because eventually they will know anyway.
Right.
Okay, so
Okay.
you don't need to consider too much,
Good.
yeah.
Sounds good. Yeah.
You can really, consider too many factors, certainly you feel uncomfortable.
Oh, nothing makes me uncomfortable.
Okay, our main professor right there. Her name is Jennifer Cole. She's really famous one. Woo!
You
Okay,
can't say that
let's
yet.
give her a big hand. 박수.
Okay, good. Yeah, okay.
Welcome to Harvard. It's very nice to have you here. Today I'm going to tell you about energy. And we're going to talk about why we are using so much fossil fuel energy. We'll talk about what happens when you use this energy. And then we'll look at the future of energy with regard to how we can move away from fossil fuels in a way that makes economic sense. So this may seem strange, but I'm going to start with a little bit of economics. Because when I teach this class at Harvard and when I teach this class elsewhere, it is called Why Aren't We There Yet? Alternative Energy. I know. So,
Maybe it's too, yeah, there. Okay, good. Yeah, yeah.
okay, now it's not again.
I can just shout. That's good, yeah. Okay.
Bravo, shout. How's that? Is that anyone? So we're going to start with looking at maybe the batteries. We're going to start by looking at energy or at economics. Because to understand energy, we have to understand money. So that's what we're looking at, money. Money, exactly. That is everything. Everything is money. So what is this word economy? What does it mean, economy? Money cycle? The flow of money, absolutely. It is the flow of money from the production of something to the distribution, to the consumption, in our case of energy, and then to the disposal or waste. And so we have this system of production and consumption, distribution, consumption, and waste of goods. And what is a good? Something, yeah, right. And in this case, energy. We're looking at energy as a good, coal, oil, natural gas as a good. When we look at economic systems, you may know, we have two end members, two extremes, and most countries fall somewhere in the middle. So we have a pure market economic system, which is capitalism. In this case, the market decides, you all decide what gets produced by your purchasing power. You have money, you buy things. The companies from which you buy get very rich, Apple, Samsung. The companies that you don't buy from go out of business, right? So that's one economic system. The decisions get made in the marketplace. And it is a very nice flow of money. In this case, we have people in the houses, and they go to business to work, and the work pays them money. And then you have a flow of money the other way. So money flows from the businesses to pay people for their work, and then money flows from the households to the businesses to buy these things. So that's an economic system that exists only in theory because we need some government intervention. The other side of the extreme is maybe North Korea, maybe other countries that have more pure command. The government decides, China, right, who gets to produce things, how much gets produced, and who gets to consume it. So very few, and I would say no countries are completely of one or the other. Countries fall mostly in the middle. Some, like the United States, South Korea, fall closer to capitalism, and other countries fall closer to pure command. Most countries are a mix. Here's the problem. It doesn't matter what kind of system you have and who gets to decide what. Economic systems are flawed. They have a big flaw. With regards to energy, this is a very important flaw. The flaw is they don't consider Earth. And so you can think of the environment, right? China has very big problems with water resources, with air pollution, right? China also has very big reserves of coal for their energy. But now they're looking at the reserves and they're looking at the rate at which they burn the coal, and they think, no, we don't have a lot of coal left. So China has a very big problem with regards to where are we going to get our energy for our rapid industrialization. So when I say Earth, I mean not just pollution, which is a big part of energy, but also how much is left. We have a finite amount. There's only so much of these fossil fuels. And when they're gone, we can't make more. So we'll see when we're talking about the big picture of energy, we have to move to a situation where we can always have more. Renewable energy, solar energy, wind, geothermal,
all of these different types of energy that we can always have more. But we're talking about money because these types of energy that we'll talk about in the second half of today are more expensive. It's that simple. They're more expensive. And we don't consider the earth, because if we did, then they would be less expensive. So our economic systems are here. Whether you're pure command or pure market, you're just looking at a system of production and consumption. If you take a step back and say everything that we produce, our computers, our phones, but this energy too, comes from Earth, and you put a dollar value on this, and then you also say once we consume energy, it causes waste that goes into the environment, then you can shift the economic system so that renewable energy is cheaper. So this whole class, again, this is where we'll be together for 2 hours, but I teach 3 classes on this at Harvard, and it's all economics. But we will look at the technology as well. Countries seek economic growth. The growth of a country's economy based on moving to and developing alternative energies could be quite powerful. So all countries seek economic growth. And we said that economy is producing, distributing, consuming, disposing of material goods and energy. Therefore, when you have economic growth, that means that you go through this system faster. So you're having more rapid rate of consumption. But with energy, when you have a finite resource and your economy is based partially on finite resources of energy, you may think over the short term, GDP, right? Gross national product, how much a country makes. And then also GNP, gross national product, how much a country makes within its borders, but then any companies it has overseas that contribute to its bottom line. The faster you go through this, the more your economy grows. But you could get to a point, if your economy is completely dependent, as most of ours are, on fossil fuels, what will happen when it's gone? You have a nice, brisk economy, everybody's rich, but then you run out of energy. And we have nothing without energy. You also have so much pollution that you can't breathe. And it must be nice to drive a nice car unless you're in the hospital because you have a respiratory problem because you can't breathe the air. So these are very fundamental things. The way that we get alternative energies that we'll talk about to be cheaper, less expensive, is in theory very simple. We internalize the external costs. Right now, we don't put a financial price on how much coal is left. Right now, we don't put too high of a financial price on how much pollution is in the environment. If we put prices on those, which means internalize the harmful costs, because right now they're external. We don't put a price on that, and we make people pay. You can use as much coal as you want, but it's going to cost you 5 times more than solar energy. What is everyone going to use? Solar. It's all money. So we want to grow economies, absolutely. Every country wants to grow their economy. So we have to work within the economy to fix our energy future so that we have the positive external costs put in a positive way. So you say to a company, oh, you're using solar energy. We will give you a tax credit. And then you have the tax credit, and you can cause the product that you make to be cheaper. And when we have another company producing the same good, and we say, oh, you're using coal, we're going to give you a tax. Sorry. And so now the good from this company is more expensive. It's the same product, but this one is half the price because we've given a tax credit and we have given a tax penalty based on your energy use. Then it makes it cheaper to do the right thing. The scary thing about this is our economy in the United States using GDP, which is the measure that we use, right, nationally and globally. From 1950 to 2000, if you look at the GDP, how much money the United States made, it looks wonderful, right? These are dollars per person. We have a great economy. It's growing and growing and growing. However, economists have done models that do this, internalize our external costs, that say in the United States, we have less and less and less resources, and we have more and more and more pollution. And when you put prices on those, look at what happens. Our economy is going down, 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 down. So in theory, this is very easy to do, but to actually put it in practice, it's quite difficult. Because the people right now that have the power in this country and elsewhere are people mostly, when we're talking about energy, who deal with coal, oil, and gas. And so when you say we're going to tax you, they have tremendous power to say, no, you're not. So it's very difficult to do, but we need to try to do that for the future, not some feel good so everybody is happy, because we will not survive without this. It's very simple. We need to take these external costs and put them into the true cost of energy, and then we will be able to shift to renewable technologies, which will clean the environment naturally. Because now we move to pollution, still keeping in mind the economic price. We can work within our economy to make alternative energy cheaper and the better way to go, and we have to because more economic models. This is an economic model of pollution. And what you see, there's a coal power plant making energy for electricity. If you tell the coal power plant, you don't have to clean any pollution. So this is the percent of pollution that's removed. You say you don't have to clean any pollution. This is the cost. It doesn't cost them anything, right? They just produce the energy and they let all of the pollution go into the environment. If you tell them they have to clean 1/4, it doesn't cost them very much. If you tell them a half, still doesn't cost very much. But if you go to 75 and 100%, it costs a huge amount of money. Now we'll look at this same graph, but we'll look at the cost to society in terms of your health. So we have looked at this red line, the cost of cleanup. Now we look at the green line, cost to society. People who die from pollution or who are so severely impacted they can't work, they can't go outside, they have no quality of life. If you say you don't have to clean up any pollution power plant, you see the cost to society is very high. If you say, oh, you only have to clean up 1/4, it's still very high. But you see, if you clean up half, the cost gets considerably lower. And then if you say 3/4 or all of it, there's no cost, of course, right? If you have coal power plant and you say any pollution you create, you have to clean it. You cannot let it go into the environment. Of course, we will all be free of pollution, but we care about our economy, and so we don't do that. So that blue line is a little bit of a scary line because it's an economic analysis that balances our economic progress with human health and the health of the environment, and what is the most cost-effective amount of pollution to remove that receives maximum health benefits. 50%, exactly. So we have these coal power plants that are producing lots and lots of pollution, and they only have to clean up half. So you can imagine this is building up in the environment. It costs money to clean pollution. And so here's where we launch really into energy. It costs money to clean up pollution, and very few people have all the money. You know this, right? Very few countries, very few people have all the money. So these are the countries, some might say, that have a responsibility to shift their economy towards clean technology and to develop these technologies. Because here, this is again United States. This is the heart of our whole day. These are the costs to generate electricity in kilowatt hours. You have all kinds of technology. This is what we'll talk about today. If you had to pay your electric bill, now you're older, you're married, you have a house, and you have to pay your electric bill, and someone says, which kind of electric energy would you like? What are you going to choose? Solar? It's very nice if you say solar, very nice. You're wonderful for choosing solar. What, however, if you also want to feed your children? Yeah, large hydroelectric. There aren't very many of these. So unless you live in China, unless you live in some areas where you have huge rivers and huge waterfalls, Canada, this is not an option. So we take that off. Now what will you use? Natural gas, and then you see also competitive with this is coal. Geothermal, also wonderful. But you can only do this where there's magma very close to the surface, as we'll see. So you can't usually use that. So in terms of a universal fuel source, we use natural gas and coal. The two colors in this are because of subsidies that the government gives, and also because of cleaning up disasters. This is Fukushima, right? Nuclear power. 10 cents if it's perfectly running and there's no problems. But if you have to clean up Fukushima, Chernobyl, 3 Mile Island, then that costs money, and so nuclear quickly becomes very expensive. Here's another problem, because we're going to use climate change, something that's very much in the news, as the pivot point today, the swinging over from fossil fuel to alternative energy. The things that are the cheapest, what do they do to our environment? They're changing the climate. We're going to have storms, we're going to have flooding, we're going to have sea level rise, we're going to have massive environmental problems because the things that we use right now, here's most of what we use, as you'll see, they're ruining the planet. They're ruining the planet because the economics work out that they are the cheapest. One other note is that, so our president, Barack Obama, when he was running for president last time, he's been in office for 2 terms, I was so happy because, and I won't talk about politics, but everybody says, oh, alternative energy, alternative energy. If you are much more efficient with the fossil fuels that you do use, you have a much longer time to phase in alternative energy because it's a big engineering challenge to put in place alternative energy. And the longer time we have, the smoother the transition. And the longer time we have, because you're using less, the less the planet will warm and these devastating environmental consequences will occur. Climate change, as we'll see, we'll talk about it a little bit. It's awful in this country. People still say, is it going on, is it not? Yes, it's going on. But it's not an off-on switch. It's not like you flip on a switch. It is, do you want 30% of Australia to burn with wildfires, or do you want 60% of it to burn? Do you want half of Bangladesh to go underwater, or do you want a quarter of it? It's a question of scale. And the longer we use these fossil fuels, and the quicker, the worse it's going to be. So this is a diagram that just shows how much energy goes in, and you see that we have over 90% of our energy in this country non-renewable, and that includes nuclear because you mine uranium. So we have 90% non-renewable. There's no reason for this. This is not right. We have this US economy and lifestyles. We leave the lights on, we leave the heats on. We have big cars and we drive them very far to go to the grocery store and leave them running while we go in because we want it to be cool in there when we come back out. So you see this makes for almost half of the energy in this country that we use, we waste. It doesn't need to be used. We use it because it's cheap. It's cheap because the government puts huge subsidies into it to keep our economy running. So you see these connections. So about half of it is wasted unnecessarily. And then another almost half of it is unavoidable because engines are inefficient, because it's expensive to turn on and turn back down a power plant. So you leave it running and you waste some energy. So some of it is unavoidable, but this is 85% almost waste of the energy that we use, 90% of which is fossil fuels. So the good news is there's so much room to change. We have a lot of room to change. So I won't go into this slide, but these are things that I just said. If we reduce waste, we can cause all sorts of good things to happen. You have this slide, you can look it over. So now we're going to spend a little bit of time talking about fossil fuels. Where did they come from? How do we extract them? And then what happens when we burn them? And I like this diagram because this shows everything for fossil fuels. This shows here natural gas, oil, and then you have also, you can look, there's some geothermal here, right? But then you have coal here. When coal is deep underground, we drill down and we mine it. When coal is at the surface, we can strip off the surface of Earth and mine it. And some things to notice about this picture, because we won't look at it in this way again, is that people talk about drilling for oil. Getting fuels out of the ground has different impacts. Drilling for oil is actually a very low footprint on Earth. You just drill a well, and then you suck the fluid up. So it's a lot kinder on the environment. When you're drilling for or excavating for coal, it's very hard on the environment. You take away whole pieces of the environment. You destroy soil, you destroy the plants, the animals. So this is a very, very difficult thing. Though we'll talk about the Deepwater Horizon, the big oil spill that happened in our Gulf of Mexico. I'll show you pictures. When you drill offshore, this becomes difficult. It's difficult to have a well that goes through the ocean and then down into the earth. And if you have an explosion, it's very difficult to clean this up and to contain this. So these are the types of fuel that we will look at. I'm carrying this and I'm not using it. Nice. Although on my screen I can see what slide comes next, so I can prepare myself. So fossil fuels, when we're talking about fossil fuels, we are talking about coal, oil, and natural gas, which is just methane, the vapor. It is one step removed solar energy. It's plants and algae that have taken the sun's energy with photosynthesis and locked their tissues into the geology. And there were periods of time that this went on very rapidly, and that's where we're tapping into. We're not making much more right now with this climate. And we're not making it on a scale that we'll be able to ever use it again. So that's why it's finite. When we use what happened back in the age of the dinosaurs, it's gone. So we'll look at how you form coal and how you form natural gas and oil, because they're different. First, with coal, I put a dinosaur here because maybe plants aren't as interesting to look at. Back in the Carboniferous period, a long time ago, there were lots and lots of tropical swamps, and they were growing and growing and growing and growing. Sea level was changing, rising and falling. And with the sea level rising and falling, we'll see in the next slide, Earth laid down and preserved a lot of plant material. It's just wetland plant material, moss, that gets squeezed and heated. Squeezed and heated, T, maybe you know temperature, P, pressure. So when you squeeze this material by the weight of the geology on top, you squeeze out the water, and when you apply pressure, it starts to heat up and squeeze more, and you cook off the organic gases, you cook off things you don't need, and you're left with increasingly pure carbon, which is coal. We like to have very, very high carbon content, because when we break those bonds by burning them, we release lots of energy. If you have stuff that's not so high in carbon content, when you break the bonds, you don't get as much energy. So this is how the coal is laid down. The top diagram, you see there's a river, and then you have a swamp at the coast, a wetland area. That's where the coal is formed. And then you have a beach, and then offshore you have the ocean. So a wetland is an area of constant plant accumulation. It's always growing up, up, up. Now you have sea level rise. This is called a marine transgression. Sea level is rising, so those environments creep backwards to picture B. When the environment creeps backwards, you're pushing down on the stuff that is buried. Temperature increases, pressure increases, and you turn the plant into P and then into coal. Now we have a marine regression. Sea level falls. It's getting colder. More and more and more of the water on Earth is in glaciers. And the same thing happens. The river deposits are pushing down, squeezing and heating it, and you lay down coal. So all coal is changed swamp material, plant material. And this is what happens in it. So you see the red line, increasing heat content, increasing carbon content, and the blue line is moisture, how much water is there. So here's the peat, just partially broken up plant material. You can burn it, but it doesn't give you a lot of energy. Some people burn it. You can use it for filtering things. As you squeeze and heat it more, you turn it into a coal that is called brown coal. Very polluting. A lot of sulfur. There's actually a lot of radioactivity in it. Mercury, cadmium, arsenic. We are told we're not supposed to eat a lot of fish, right? Why? What chemical is in the fish? What? Yeah, okay, yeah, absolutely. That too, yeah, absolutely. And what else? Mercury. The mercury, so both, absolutely PCBs, but mercury, globally, we can't eat fish because it's unhealthy, especially women and children. And the mercury comes from coal. This is a highly polluting energy form. You squeeze it more, you turn it into bituminous and then to anthracite. When you go to anthracite, the highest form of coal, the pollution gets lower. So there's less pollution, not as much mercury, not as much radioactivity, not as much sulfur, which makes acid rain. And so we prefer to use just anthracite coal. That would make coal a lot cleaner. However, we don't have much of it. Most of our supplies are the bituminous coal, which is highly polluted. This is a blow up of that previous diagram, and you can see where it is close to the surface, we prefer to strip off the surface of Earth and bust it up, break it into small pieces, and then just bring it to burn in an energy plant. Where it's so deep that we won't excavate the whole surface of Earth, we drill underground like an elevator, a mine shaft going way down. We break it up, and then you take it up in the elevator and burn it. This is dangerous for workers. Sometimes these tunnels can collapse. Poison gases can build up. But it's better for the environment because you're not digging away a whole part of Earth. These days, we also do something called mountaintop removal. It's called strip mining on steroids, they call it. Mountaintop removal, where there's coal in mountains, you just blast off the top of the mountain, and then you take the coal. And these are pictures of an area to the southwest of here, New York, Pennsylvania, areas where there are a lot of coal. You blast off the top of the mountain. This is very bad because you're destroying the fragile environment at the top of the mountain. And then they take it and they dump it into the rivers at the bottom of the mountain. So you pollute the rivers and you poison the rivers. But we do this a lot, and it's in areas of the United States where a lot of poor people live. So when you're poor, you have no voice. And so we do this. Poor people live in these areas. Here's a picture of North America, all of North America, and the types of coal. And again, you can see we would love to just burn anthracite, the blue distribution, but do we have a lot of it? No, what do we have a lot of? Bituminous. And the picture is the same in other countries. You have a lot of coal that is highly polluting and not very much clean coal. So the clean coal, how do you think it ranks with economics? Is it cheaper or more expensive? Very expensive, yeah. Very expensive to buy anthracite coal. Just briefly, we already said this, but the environmental problems that happen because of coal are worse than any other pollution or energy source. Strip mining, you take off the surface of Earth. No plants, no animals live. And you strip off soil that we could otherwise use for agriculture to grow food. You take huge parts of Earth and you make it not useful. Acid rain, there's a lot of sulfur in coal. And when you burn the coal, sulfur goes into the atmosphere, mixes with water, and you have acid rain that poisons water, poisons land. Can also poison agriculture, because the higher the acid content, the more toxic it is to the plant in a natural system. But we care about this for our agriculture. We're not going to be able to grow food as well as we used to be able to. Climate change, we'll talk about. Lots of ash are created. There's fly ash, which is very, very fine particle size and goes out into the atmosphere. It's very hard for humans to breathe this. And then there's bottom ash. That is big particle size, so it doesn't fly away, but it's very toxic. That's where a lot of the radioactivity is and the metals. And so we have to be careful about disposing of this. But in China, right, the biggest emitter of these gases and one of the biggest users of coal, there's not environmental regulation in place for this ash. So you just dump it. Air pollution, we already said, and soil erosion, we said that. We destroy the soil when we get coal. One small note, because we will talk about technology in this class. Maybe you hear about, we will make clean coal. So we're going to take dirty coal, and turn it to clean coal. The good news is, yes, you can do this. It's called coal gasification. You make something called syngas, synthetic gas. You use iron, you use cobalt as a catalyst to turn coal into clean methane gas. This is a reaction chamber. I won't go too deeply into the chemistry, But what you do is you take the raw coal and you crush it up into a powder, very fine powder. And you put it into a reaction chamber with steam. I'm sure you know about water, right? It has the highest heat capacity of any liquid. So you have to use huge amounts of energy to heat up water to turn it to steam. You also have to use huge amounts of energy to pulverize the coal. So you're putting in a lot of energy into this process, and then you have air or oxygen coming in. And the reactions you can see here, you take coal reacting in the presence of steam, and then also cobalt or iron, and you create methane, which is a clean gas. You're able then to take away, slag is the ash, the leftover stuff that didn't react. You're able to take that away and put it into a hazardous waste facility. You're able to take the unreacted material that could react later. You can put it back into the reaction chamber. You take away the sulfur, and you can actually sell that. Matches, so when you're striking things, we use sulfur for many applications, so you can recover that and sell that. And you end up with clean methane gas. So yes, it's possible to make coal clean. However, why don't we do it? Super expensive, right? You could just burn that, right? And so it's super expensive, so we don't do it. It doesn't make sense. What now? So I won't talk about this. I'm just showing you some statistics. This isn't terribly important or interesting, but just seeing who has the coal and who burns it. About 2/3 of the coal, China, Russia, India. It's used to make 1/4 of the world's commercial energy, over half of our electricity, 3/4 of our steel, and China and the United States are the big users of this highly polluting thing. When we talk about climate change, it's good news that the United States and China are talking. They just came to an agreement this month on what shall we do about climate change. And there will be a big conference in Paris in December for the whole world to say, what shall we do about this? So this also, we've discussed this. This is really a summary that shows why we like it. Really, the only reason we like it is there's a lot of it and it's cheap. The cons, the disadvantages, you can see, maybe you think, far outweigh the pros. Just because we have a lot of it and it's very cheap doesn't mean we should use it, because it destroys the environment in all these ways. I won't read them all to you. You have them here. It destroys the environment in many ways. It ruins human health, and it's non-renewable. Once we're done burning it, it's gone. There also, this I find so fascinating. I'm obsessed with this. I like to read about this a lot. Sometimes, because of the gases that build up in the underground mines, the mines will catch on fire, and there's nothing you can do, because it is a high heat content, high burning coal. You cannot pump that much water underground. And so what we do when these coal mines catch on fire, we just go away. And you have to abandon the whole town. We have a town in Pennsylvania, Centralia. It was a whole town. Everyone just moved. The streets are melting. Things are melting. There's fires that come up through the cracks. So everyone just goes away. There's no way, well, I guess, yeah, economically it doesn't make sense to put out the fires. So these coal fires underground rage. China, Uzbekistan, United States, especially Pennsylvania, you just leave. And there's huge amounts of greenhouse gas going into the environment as a result of this. So another sort of fun fact about coal. Moving on to petroleum and natural gas. So petroleum, crude oil, and then natural gas we looked at for a minute with coal, methane. This is the problem with economics, at least in this country. Our market, our economic market, is flooded with cheap natural gas. It's so cheap. And so the incentive to develop alternative energy is not there. We have lots and lots and lots of cheap natural gas. It's cleaner. It's much cleaner than coal. It's the cleanest burning of the fossil fuels. So this is good. Not fabulous, but okay. So it's amazing that we have any of this at all, any oil or natural gas at all. Why? Well, this is the last step, so let me just talk you through. Maybe I go up to this one again. Oil, natural gas come from algae, microalgae, phytoplankton. And they live in the tops of the ocean and in big, big lakes. But because of the way that the environment works, usually when these algae die, either animals will eat them or ocean currents and oxygen will break them up so that their materials can be recycled, so they don't get to make petroleum. Sometimes they die at a very rapid rate and they start to go down to the bottom of the ocean. If that happens, then ocean currents can sweep them up and then they'll just go elsewhere and go away. So no oil. Sometimes you have phytoplankton raining to the bottom of the ocean along with sand or silt, fine sediment. That's the first step. We need that. Lots and lots of phytoplankton going to the bottom of the ocean, mixing in with sand. And you lay down this thick sequence of rock that has a lot of algae in it. Now, just like with coal, when you start burying it deeper and deeper, temperature increases, pressure increases, and you change the phytoplankton, the algae, into hydrocarbons of different lengths. You know hydrocarbons, right? Just carbon chains with hydrogen around them. Different lengths. Methane is the simplest, and you have longer and longer chains of hydrocarbons. So now you've changed the algae into hydrocarbons, but that's not really historically has been good because it takes more energy historically to break up that rock, to bring it to the surface, and to extract the oil and leave huge amounts of shale and sand over here. It takes more energy to do that than you would get from that oil. Now we've developed what is fracking. What? Yeah, right. So we've developed, and I'll show you a picture of this, we've developed a method where you don't have to break it up and bring it to the surface and do this physically. Fracking, high pressure fluids with a lot of chemicals in it that open up the pores, that cause the petroleum to move along, and then you can extract it more cheaply. The problem is what? Some of the chemicals they use are quite toxic, and the companies try their best to make sure all the chemicals are recovered, but they don't always do a good job. And so these chemicals are showing up in our drinking water and giving people very bad health problems. So, hydrocarbons. You have this bed that we can use fracking for, but historically we haven't been able to use this. So then what you need is for geology, tectonics, to change the conditions of the rocks so that these hydrocarbons get concentrated and they layer out due to density differences. So we have here, this is called an anticline. Tectonically, this region got squeezed and the flat-lying layers got buckled upwards. Now, if that just happened with just sand, the oil and gas would come out to the surface and the rain would wash it away. But sometimes you have a layer, in this case the brown layer here, of shale that is impermeable. Water and fluids can't pass through it. So now this is a great situation because you have the layering due to density differences, and you just go and you stick a well right here. You can suck out all the gas, suck out all the oil, and you have your energy. Very easy. but this doesn't happen very often. Also, an earthquake here. There's an earthquake fault here. So you have this sand, and if you didn't have the earthquake, the gas and oil would just leak out onto the surface and be washed away by wind and rain. But you have an earthquake in a squeezing, compressional environment. It will momentarily liquefy the sediments that are there, turn into igneous rock that traps it. So these are called traps. So now you've trapped this, and you can drill it here. Petroleum geologists love earthquakes because it could be that you expose and you trap these natural resources. In the Middle East, Saudi Arabia, the oil-rich countries, they're dry countries, and so historically we have laid down a lot of salt. Salt behaves like a solid at the surface, but if you put it under a lot of pressure, it can flow. It flows upwards. And so the type of oil traps we have in the Middle East are called salt dye piers or salt domes. The salt pushes upwards and causes the buckling upwards of the sediments around it. So geologists look by radar, looking underground, ground-penetrating radar for salt, and they know to drill right next to it. And the same thing here. This is sea level rising and falling. The difference between the sand, this is all beach environment, and this is offshore environment. Sea level has risen and fallen, and you have gas and oil being trapped in these pockets. The environmental problems from oil and natural gas are much lower. We prefer to use this method of fossil fuel energy generation over coal. But what we have is when we frack, when we try to get the oil out of these sands, sometimes chemicals, as I said, are left over, and I'll show you a picture of this. Then, air pollution, because it's still a fossil fuel, it still can cause climate change, and especially in oil, there is some sulfur and other things in it. Air pollution, acid rain because of the sulfur. When the air pollution mixes with water, you have acid rain. Climate change, which we'll talk about. So again, just a blow up of the picture that we saw. There's the trap, and we just stick in wells and suck that oil and gas out. Very simple. A lot less difficult and a lot easier on the environment. Once you suck it out, you have something called crude oil, which is a complex mix of lots of different hydrocarbon lengths. Looks like this. We can't do much with crude oil. We have to separate out the different hydrocarbons, and I'll show you how we do that. And then this is oil shale. This is what we frack with. We put very high pressure water down, cause cracks, and then chemicals dissolve the oil, and then we bring it up through recovery wells, separate the chemicals from the water, from the oil, and then go over and over again. So this just shows what we do when we extract it in that previous slide. Primary is when you suck it out of the wells. Secondary, you actually put water down in there to rinse out the pores, and then you can suck the remaining stuff out because it sticks to the sediment. Tertiary, third stage, you inject steam, and that further cleans the pores. So it just makes sure you get every last drop. Once you get it out, you refine it. So that means you separate it by high, medium, and low volatility, the ability to pass into gas phase. And then you transport it. Every step along the way you could cause problems. There's a picture of an oil field pumping this oil out. You may hear of OPEC. United States is not a member of OPEC. 13 countries have almost all of the reserves, and so they speak together and they collaborate on selling, buying, and fixing the price. This is something called a partitioning column. The partitioning column is how we separate this complex mix of different hydrocarbon lengths. Oh yeah, so we need a break soon, right? Let me finish with this because you said about 45 minutes, so just finish this up. Okay. Okay. do you want me to finish this one spot and then we can, so this is how we separate it. You have the furnace, the heavy stuff sinks, and the lightest stuff goes up into the column. The lightest stuff goes into our houses and our cars. The heaviest stuff we use to make roads. There's just a picture of fracking. And so you inject this stuff and you break up the rocks and you extract the oil and gas. This is the advantages and disadvantages. Again, we have a lot of it, not as cheap as coal. The disadvantages, we've talked about them all. Maybe you would think this is not worth it, right? Especially when we have, this is the extraction of oil off the coast, leads to serious harm in the ocean. Because it's a complex mix, what happens is some of it goes into the atmosphere and causes air pollution. Some of it floats on top of the water and coats birds and coats the top of the water. Some of it dissolves in the water column and causes water pollution. Some of it sinks to the bottom and coats the animals and plants at the bottom. And it is very difficult to contain and very difficult to clean because it's so complicated. If you dumped coal into the ocean, it would just fall to the bottom and you pick it up. This is very difficult to clean, especially, again, with this offshore stuff. I'll leave with this one. Oh, no, we already talked about sources. I'll leave you with this one. So the last pro-con list was oil and gas. This pro-con list is natural gas, methane. This is the best of all worlds of fossil fuels. We have lots of it, and it's clean. When you burn it, yes, there's some carbon dioxide, but not a lot. So if we have to use fossil fuels, I'll leave you with this with the break. This is what we want to use. So let's take a break, and we'll come back in about 20 minutes or so. 10 minutes, okay. Yeah.
We'll be back. So